Yes, sir.
Mass of pilot 75 kilogram. What will be the greatest mass of equipment that can be added when operating in air of density? So density of air, rho F of air, we have 1.25 kilogram per cubic meter. And how will this figure change if helium, which has twice the density of hydrogen, under the same conditions were to be used? Okay, so the whole concept is that for the hot air balloon to float, mass of everything, including the balloon, the pilot, then the equipment E, this must be equal to the mass of air displaced. If you want to express this in terms of mass, if you want to do it in terms of weight or upthrust, then weight of balloon, pilot, equipment to be added. Okay. And the hydrogen. I've noticed it, exactly. And the hydrogen. So mass of balloon, pilot, hydrogen gas, plus the equipment. Okay. So balloon, pilot, hydrogen gas, plus the equipment must be equal to the upthrust. Whichever, so it's about whichever way you want to go. We were given the mass of balloon 100, mass of pilot 75, but we do not have the mass of hydrogen gas. So the mass of hydrogen gas would be equal to the density of hydrogen gas times the volume of the hydrogen gas. The density of hydrogen gas is 0.09. The hydrogen gas will fill the volume of the fabric, which is 2,000 meter cube. So we have 9/100 times 2,000. This, and this is giving us 180 kilograms. So it means that 100 plus 75 plus 180 plus the mass of equipment must be equal to the upthrust mass of air displaced, which will also be the density of air 1.25 times the volume of air that will be displaced, which will be equal to the volume of the balloon fabric. So let's help me multiply 1.25 by 2,000. 1.25 by 2,000. Yes, Anita, Melda, and the rest of you. I'm listening.
2,500.
Okay, so we have this is 175 plus 180 plus ME is equal to 2,500. Okay, so that 175 plus 180 would give us 355 plus mass of equipment equal to 2,500. Therefore, the mass of equipment that can be carried would be 2,500 minus 355. And this would be equal to 2,000. This will be equal. Hello, can you hear me?
Yes, but
I'm coming. All right. So this would be equal to 2,145 kilogram. Okay. And so therefore, the greatest equipment, what is the greatest mass of equipment? So ME. Therefore, greatest mass of equipment that can be carried is equal to 2,145 kilograms. And as I said, a lot of you got this right. So now if the gas within, how will this figure change if helium, which has the density, which has twice the density of hydrogen? So it means that density of helium must be equal to 2 times the density of hydrogen. So this would amount to 0.18 kilogram per cubic meter. Now, when we change the gas, it is just the mass of the gas within the tube that will change. The mass of the pilot will not change. The mass of the balloon will not change. It's just the mass of the gas within the tube that will change. So mass of helium this time around will be equal to the density of helium, which is 0.18 times the same volume, 2,000. Okay. And what is 0.18 by 2,000 class? Hello? Are you people? So this is 360 kilograms. And so when we fill it with helium, the mass of balloon 100, mass of pilot 75, the mass of the helium gas within 360 plus the mass of equipment must still be equal to 2,500, which is the mass of air that will be displaced. So when we total this plus 175. This time we'll have 535 plus the mass of equipment that can be carried equal to 2,500. Therefore, mass of equipment that can be carried would be equal to this difference. Okay. Which will be equal to 1965 kilograms. So when we change the gas to helium, this will be the greatest mass of equipment that will be carried. Please, any question? Is there any question? If you don't understand something and you want me to explain. All right. So you can do it using mass or using weight. Okay. When you want to use weight, it's just a matter of expressing everything in weight as you do. But the question is on the greatest mass. So, all right. Once there is no question, it means we can continue. Let me see if there are some messages. Okay. Okay, vectors. 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 What is a vector quantity? Daisy. Daisy, what is a vector quantity? Daisy. Daisy, I'm listening. Okay. Juniors, go ahead. What is a vector quantity?
This a vector quantity is a quantity that has magnitude and moves in a specified direction.
Come again.
It is a quantity that has magnitude and moves in a specified direction.
So vector quantity has magnitude and direction. Okay. Its colleague is scalar. So a scalar quantity has no direction. Only has a magnitude and no direction. Let's discuss examples of quantities that are vector in nature. Yes. Godfred, 1. Okay, Gwenziwa, go ahead.
Acceleration.
Acceleration is 1. More views. Give me about 8 examples or 10 examples of quantities with magnitude and direction. Acceleration, Anita, talk, Anita. Godfred.
Velocity.
Velocity. If your hand is up, please go ahead. If your hand is up, pardon?
Momentum.
Momentum. We are listing about 10. So, velocity, momentum.
Displacement.
Displacement.
Force.
Force.
Weight.
I'm listing them, so I'm coming. Force. Weight. We have 6 so far. we have said so far? I'm listening. Acceleration, velocity, displacement, momentum, force, weight. Daisy,
Pressure.
come again.
Pressure.
Pressure. Moment. Momentum, moment. Yes.
Magnetic field.
Magnetic field.
Angular momentum.
Once you talked about magnetic field, let's also talk about electric field. Okay, I think we've listed more than 10. Okay. So these are vector quantities. Nana Kwentua.
So please, I have a question.
All right.
So please, how is pressure a vector quantity?
Pressure is force per unit area. Force has a direction. Area is scalar. So the direction of pressure is the direction of force. Are you okay?
Yes, please.
So when you hang a bucket around your arm, the direction of the weight of the bucket is where the pressure exerts. Okay, so how do we represent this? Let's take distance and displacement. By the way, what is distance and what is displacement? I'm listening. Distance and displacement. Yes, what is a distance? Anybody? Gideon.
The distance is the interval between 2 points.
In a straight line. Okay. So the interval between 2 points in a straight line, this is distance. So over here, we are only interested in the amount of movement of the body. Now, what is displacement? Yes, Saki. Oh, another hand is up. Okay, let me call somebody. Hafiz. If Hafiz cannot hear me out, either take it up.
Displacement is a change in position from one place to another.
You are not wrong, but you are also lacking some details. The change in position of a body from one place to another with respect to a certain reference point. Okay, with respect to a certain reference point or a certain initial position. So either move from here, this is your this is the reference point A, and then get to this point B. So the change in position with respect to where you started, A, B, with respect to this is this displacement. So over here, we are actually interested in the direction of the body with respect to where the motion actually started. So if we are indicating this, because we are as well interested in the direction, we use an arrow to indicate the direction. So that's the difference between distance and displacement. In displacement, we are only interested in the amount of movement, distance, the amount of movement. Whereas here we are interested in both amount of movement and direction. So all vector quantities must be indicated with magnitude and direction. So the interval between the 2 points is the magnitude, and an arrow drawn at the middle or at the end indicates the direction, meaning this amount of movement is measured from a point A to point B. If the amount of movement is from B to A, then the arrow, this is A, this is B. The arrow must be indicated in the opposite direction. Okay, so we indicate vector quantities with this bold line and then an arrow either drawn at the middle or at the end to indicate the direction. So if it's about force, if it's about acceleration, velocity, momentum, we must indicate it with a bold line, okay, with an arrow either in the middle or at the end. Class, is that okay? Are we okay?
Yes, sir.
Okay. Let's look at how do we add vectors, addition of vectors along one plane. Addition of vectors. Before we discuss addition of vectors along one plane and two planes, you see, we indicate it by a bold line starting from a point and then the arrow, okay? The vector representation, this point where the motion starts is the tail of the vector. Then where the arrow is, in this case, this is the head of the vector. So a vector has a tail and a head. If it's about having the arrow in the middle, then the starting point is the tail of the vector, and then the ending point is the head. So a vector is drawn to have a tail and a head. Take note. So addition of vectors along one plane. A body A, so let's take what we mean by one plane. One plane here refers to, let me draw a straight line. If I draw a horizontal line representing the x-axis, if this is the center, then it means that this point is a positive x and this is the negative x. This can also represent east, and the negative x can also represent the west. So if an object is moving along one plane, either it is moving along the x-axis or the y-axis, or it is moving along east-west or west-east or north-south. Okay, so any movement along one of the axes, whether x or y, is what we are describing to be movement along one plane. So, example, I have a body or one body moving with a velocity of 10 meters per second. Once velocity is a vector quantity, we need to show the magnitude and then the direction. So this is an arrow to indicate the direction, and the magnitude of this velocity is 10 meters per second. Another body also moves along the same plane. It's moving along the same plane with a velocity of maybe 20. This has a velocity of 20 meters per second. Okay. And we are asked to calculate for the resultant velocity. The resultant velocity. Let's consider these two velocities acting on a body. And this is the body. Okay. So the body is being acted upon by two velocities. One of magnitude 10 meters per second. U is another body. Okay. Another body also moving, acting on the same body with a velocity of 20 meters per second. And the question is that determine the resultant velocity. Anybody to help? How do we calculate for the resultant velocity on the body? This is the body. How do we calculate the resultant or the total velocity acting on the body? Any idea? Okay, if no idea. So when two vector quantities act along the same direction, the resultant or the totality of that particular vector quantity is determined by summing up all the forces or all the vector quantities along that direction. So it's a summation of the individual velocities. Okay, it's a summation of the individual velocities. Example, a practical application of this is that when a car breaks down, okay, on the road, and people are up there, you are asked to move the car from the road. What you do is that you call people to come and then push in the direction of intent. Okay. Now when they push, they must all push or exert the force in the same direction. Okay, it wouldn't work out when some people push along one direction and others push along the opposite direction. That will not work. But for the car to move to the intended destination, all the people must stand at one side and push the body to a common direction. Please, are you with me? Class, are you with me?
Yes, please.
By this, what it practically means is that they are combining their individual forces to move the car. So if we want to determine the total force, which is actually moving the car. The total force must be the sum of all forces acting on the car. So when vector quantities act along one direction, the resultant force, the resultant vector is the summation of all the individual vector quantities. So a velocity of 10 meters per second due is another velocity of 20 meters per second due is acts on the body. So the resultant velocity must be summation of all the individual velocities. So 10 plus 20. And this will be equal to 30 meters per second. So the point to note is that when vector quantities, a number of vector quantities act along the same direction, the resultant is the summation of all the vector quantities. Are you okay? So let's understand what we mean by resultant, the resultant vector. We define the resultant vector. We define the resultant vector as a single vector. Please, are you writing? We define a resultant vector or a resultant force. Since we are generally talking about vector, let's use vector as a single vector whose effect, a single vector whose effect is equal to the combined effect of a number of vectors. A single vector whose effect is equal to the combined effects of a number of individual or single vectors. Okay, so here you were given two velocities, v1, another velocity v2. The individual vectors are v1 and then v2. And when we calculated, we saw that the resultant velocity is equal to 30 meters per second. What this value means is that what 30 meters per second alone can do, 10 meters per second and 20 meters per second, when combined, can do the same thing. Okay, so 30 meters per second is that single vector whose effect is equal to the combined effect of 10 and 20. Anita and Co, are you okay? Extra, are you okay?
Yes.
All right. So it doesn't matter the number. Let me give a clear question and see how you can. So we have this. We have an object or a body. This is pushed by a number of forces. F1, F2, F3, along a common direction. So this is F1. F1 is equal to 15 Newton. F2 is equal to 10 Newton. F3 is equal to 20 Newton. Help me calculate for the resultant force. What will be the resultant force acting on the body? Yes, Gideon.
45 Newton.
So, since all the forces are acting along the same direction, the resultant force is the summation of all individual forces. So 15 plus 10 plus 20. So we have a total of 45 Newton, meaning that the effect that can be given by F1, F2, and F3, only 45 Newton would produce the same effect. Are we okay? So whether the bodies are moving, the vector quantities are moving along the positive east, west to east, or east to west, or south, north, south, so long as they are moving along the same direction, this is how to determine the resultant force. Let's look at the direction of the resultant force. The direction of the resultant force. Look at this example. Okay, 3 forces acting on this body. This body. What do you think will be the direction of the resultant force? Ella. Ella, please speak up. Hey, Ella, your voice is down. It will be due east. Okay. So Ella is saying that the direction of the resultant will be due east. Yes. All the forces are acting on the body along one direction. So this resultant force of 45 must act along that same common direction. So it will be due east. Okay. Gideon. Okay. As usual, it's a mistake. Let's look at determining the resultant force. Okay, when two or more vector quantities move along 2 dimensions. When the number of vector quantities move along 2 dimensions. So we have the body. Let me produce 9 sketches. This is the same body. So this time around, the body is being pushed by a number of forces acting along the same plane, along one plane, but not in the same direction. So F1 acts due east, F2 acts due west. They are all acting on this body. How do we determine the resultant force or the net force between F2 and F1? Net is the difference. So, Ella. Ella, speak up.
I was saying you find the difference between the two forces.
Okay. So Ella is saying that under this situation, we find the difference between the two forces. So if F2 is greater than F1, Ella, what will be the resultant force? Ella, if F2 is greater than F1.
The resultant force will be F2 minus F1.
So if F2 is greater than F1, the resultant will be F2 minus F1. And Ella, what will be the direction of the resultant force?
Say to be neutral.
I don't understand you. What do you mean by to be neutral? Okay, let somebody else.
No, it's not be neutral, sorry.
What will be the direction of the resultant force? Elikem's hand is up. Elikem, let's hear from you too.
So the direction of the force will be due west because the F2 is greater than F1.
Okay, so when two vector quantities act oppositely on a body, the resultant is the difference between the forces. Okay, so it basically depends on the magnitude of the forces. If they are equal, if all the forces are equal, the resultant force will be 0. Okay, and the body can be stationary. Okay, we'll get there. But if F2 is greater than F1, the resultant force is F2 minus F1, and the direction of the resultant takes the direction of the larger force. So let's use values. F1 is equal to 20 Newton. F2 is equal to 5. What will be the magnitude and then the direction of the resultant force here? Yes. Gideon, let others speak. Let me call some people. Let me call some people to also speak. Okay. Hafiz.
Yes.
What will be the resultant force under this condition or situation? If F1 is 20 and F2 is 5, what will be the magnitude of the resultant and the direction? Frank. Frank, I'm listening. Okay, Gideon, take over. Elikem, go on. I'm listening.
So please,
Yeah.
since the force of the first one, F1, is greater than F2, it will be F1 minus F2. So the resultant force is 15 Newton.
So 20 minus 5, okay, which is 15 Newton. What will be the direction of the resultant? So, and will be, please, when I mention your name, be snappy with your responses, okay? Due east. Yes. Okay. Solve this for me. Solve this question for me. We have 3 forces acting on this one in this direction. F1, F2, F3. This is 100 Newton. This is 12 Newton. This is 55 Newton. Then we have two other forces. This is F4 40. This is 15. F5 15 Newton. Then we have another one from this direction, which is F6. F6 is also 25 Newton. We are to calculate for the resultant force and determine the direction of the resultant force. So determine the resultant force and the direction. Note that F1 is equal to 100 Newton. F2 is 12 Newton. F3 55 Newton. F4 40. F5 15. And finally, F6 is 25 Newton. So start with, you are to determine the magnitude and direction of the resultant force. Are we through? Class, are we through?
Yes, sir.
All right, so let's do it so you mark yourselves, okay? I'm going through it with you. So you mark yourselves after. Okay, so how do I go around this problem? You need to sum up all the forces along one common direction. The directions are due east and due west. Okay, so it's summation of forces. Eric, your hand is up, or it's a mistake. summation of forces due east. So we have F1 plus F2 plus F3. Okay, please sometimes note that we can possibly have a force here which is acting due east, as I did, okay, here. So it isn't all the time that you have the forces being at one side. It can be mixed. So you sum all the forces due east. So we have 100. You sum them up. 100 plus 12 plus 55. Okay, this is giving us
167.
167 Newton. Let's determine all the forces due west. Due west, and we have F6 plus F4 plus F5. This is also 25 plus 40 plus 15.
Making 80 Newton.
That is what?
80.
80 Newton.
This is 80 Newton. Okay, so it is as if all the forces are resolved in one direction. Due east, we have 167 Newton. Due west, we have 80 Newton. So the resultant force, therefore, is the difference between them. So 167 minus
Minus
80. And this is equal to
87 Newton.
87 Newton. That's the resultant. Frank, your hand is up. Oh, it's a mistake. Okay. So the resultant is 87. And what is the direction of the resultant?
It's due east.
Is due east. So if this is a box, that is being pushed, the box will move in the direction due east. What we are discussing is similar to this game where people pull rope in opposite direction.
The
What's
tug
the-
of peace.
What's the name?
Tug of peace.
It used to be tug of war. Yes. Okay. So the people that will produce the larger pool always wins. And you realize that whoever wins would pull the other people in their direction. So the resultant force always take the direction of the larger force. Okay. Frank, your hand is up. It's a mistake. Okay. So please, how many of you got it? Scored everything? How many of you scored everything? I'm interested in more hands. Okay. Okay. Oh, more hands. Thank you. Now let's look at, so please, all that has been discussed so far, we are looking at forces or vector quantities moving along one direction, okay, or along one plane. Now the next thing we are going to look at is what will happen if they move in two planes. Yeah, please mute yourself if you haven't muted. Or I mute all. Okay. Didier, your hand is still up. Okay. Frank, I've been calling you, but you keep being silent.
Sir, please, his mic is not working.
Oh, then you should send a message. Frank, send a message if your mic is not working, okay? All right, so let's now look at vectors along two planes. One with two planes, what I mean is that one moving along the x-axis, another along the y-axis. So vectors, the resultant of vectors along two planes. So here, Frank, if you still have something to add, send a message, okay? So this is due east or positive x, west. This is north, south. So we have a force acting due south. This force has a magnitude of 15 Newton. So it is acting. Please, we can bring it up or down. Okay, so long as we are not changing the direction and the magnitude is the same. Then we have this one. Okay, so let me bring it here. This is F1 acting due south. Its magnitude is 15 Newton. Then F2 acting along due east. Its magnitude is also 30 Newton. We are to determine the magnitude and the direction of this force, of these forces. This is one. Another example. So question one, question two. I want to give you two questions and then take attendance. So positive x, this is y, minus y, negative x. We have two forces. This is due north or y-axis. This its magnitude is, let me change it to other vector quantities. I used forces earlier. Let's use displacement. So the displacement of this body, D1, is 150 centimeter due north, and this is 60 centimeter due east. Determine the direction, the magnitude and direction of the resultant forces in the two cases. So determine the resultant force and the direction. And here, the resultant displacement. Displacement and the direction. So I want you to think through it. Think through these two questions. Okay, whilst I take attendance. Okay, and I'll get back to you to discuss that with you. Start with. back to you. Let's look at the question given to the house. So here we have two forces, F1 and then F2. Okay, acting along the south, F1 acting due south and F2 acting due north. If you have vector quantities, you see over here, the two vector quantities are perpendicular to one another. Okay, so they are acting in this manner. The angle between them is 90. F1 acting downwards, and then F2 acting along east. To get the resultant, when you look at what we have here, and both of them are acting on a body which is at the origin. Okay, so what we have here is a body on which the two forces act simultaneously. To determine the resultant, look at their direction. This is going east, this is going south. They don't have a common direction. You can't tell where both of them are going. So to determine their resultant, you have to realign their directions so that the directions of both vectors will follow a certain sense of order. Okay, class, are you there? Are you people there?
Yeah.
Okay, so to do that, you have to realign their directions so that it will be orderly. The directions of both vectors will be orderly. Because looking at F2, F1, you can't tell where both of them are going. Okay, how do we do that? We can do that using what we call equal vectors. Equal vectors. Equal vectors. Vectors are said to be equal when they have the same magnitude, the same direction, and when both vectors are parallel to one another. So I will create, to realign their direction, I'll create an equal vector of either F1 or F2. How do I do that? If I want to create the equal vector of F1, I need to measure the magnitude of F1. Its magnitude is 15. So I'll measure 15 Newton and then place it on the head of F2. So the equal vector of F1 must be placed on the head of F2. And if the new vector has the same magnitude, direction, and is parallel to F1, it is equal to the equal component of F1. So I'm using the broken line to create the equal vector of F1. And I need to make sure that F1, what I'm doing, has the same magnitude as this and the same direction. So if this is 15 Newton, this must also be 15 Newton. This is 15. This must also be 15. And the direction of F1 is due south. This must also have a direction due south. And if this one and this one are parallel, then I can say that this is the equal component of F1. Class, are you okay? Are we okay? Okay. Let me take a new page. So I have F1 acting due south, F2 acting due east. And now this is the direction due is. The magnitude is 30. So this is F2 is 30 Newton. F1 is 15 Newton. Looking at directions of F1 and F2, you cannot predict place and they are perpendicular to one another. Okay. You can't tell where both vectors are or forces are going. There's no common direction to both. They rather have individual directions. So to determine the resultant, okay, you need to realign their directions so that the directions of both will follow a certain order, or you can predict where both are going. As it looks, you can't tell where they are going. Class, are you okay? And to realign their directions, what you have to do is that you have to create equal vectors. Create equal vectors. And vectors are said to be equal no matter where they are. If they have same magnitude, and direction. Two vectors are said to be equal when they have same magnitude and direction. And both are parallel to one another, no matter where they are. So it means that one vector can be here, another vector can be here. So long as they have these common features, we can say vector A is equal to vector B. But for them to be equal, they must have the same magnitude, same direction, and they must be parallel. Please, are you okay? Class, are you okay?
Yes, please.
Okay, so I'm creating equal vector of both F1 and F2. And look at how I'm going to do it. I first need to measure the same magnitude of, I'm doing it for F1. So measure same magnitude as F1 and put it on the head of F2. So I just need to make sure that I'm drawing a magnitude of F1, which is equal to this one, which is equal to. So if the length is the magnitude, so I must end somewhere here. Then I also need to make sure that this one, the broken line one, has the same direction as. So it is acting due south. I need to give this direction due south. And I also need to make sure that this one is parallel to this one. Once it has all these features, I can also name this as F1, meaning this is the equal vector of this. But in order to create a distinction, that is why one is in a broken line form and the other is in a bold line. Class, are you okay here?
Yes, please.
All right. Then I can also create an equal component of F2 and place it on the head of F1. I need to measure the same magnitude as F2. So this length from here to where the arrow is, I must measure the same thing. From here to this. Same magnitude. Then what is the direction of F2? Due east. I must also give this a direction due east. Then I can say that this is also F2. Now look at something. After doing all this, look at this. Look at the direction of this F2 and this F1. If you look at it from below, this direction plus this direction, you can now see that both vectors, this is F2, F1, both of them are coming to this destination. So it's like moving from here, then continue downwards. If you look at it below, this is also moving downwards and then continues horizontally. So to determine the shortest distance or the resultant, if I draw a vector, okay, from the tail of F1 to the head of F2 here, this distance will be equal to the resultant of both. Okay, so if F2 is going horizontal, F1 is coming down, then it's obvious they are all coming to this destination. No matter where you take it, either up or down, when you want to go this way or you want to come this way, no matter where you look at it, you can tell that both are all coming to this point. Please, is that clear? Are you okay?
Yeah.
Meaning that if I draw a vector from the tail of F1 to the head of F2, this will be the resultant of both F1 and F2. So this is the resultant force, F resultant. Okay, once this are perpendicular to each other, it means that this is also perpendicular in that order. So what I have here is F1 due south perpendicular with F2 due east. This is F2, F1, and they are perpendicular to the east. And so the resultant is this. Now, class, by doing this, I've now realigned their direction. You can now say that F2 and F1 are coming to this point, O, because their directions follow a certain order. When you do that, we say that the directions of F1, F2 plus F1 must be equal to FR. And this FR, which is equal to F1 plus F2, we say that this obeys the triangular law of vector addition. This obeys the triangular law or triangle law of vector addition. Once we're able to realign their direction, then when I add F2 to F1, it must be equal to the resultant. Okay. Now this triangle law of vector addition can only be used to determine the resultant when you have a scaled drawing on graph. On a scaled drawing, when you add, once you realign their directions, when you add F1 and F2, it must be equal to the F resultant. Okay, class, are you there? So the triangle law of vector addition can only be used to find the resultant if we have a scaled drawing. A scaled drawing. Are you okay? Class, are you okay?
Yes, please.
Now, if it's not a scale drawing, you must use formula. If drawing is not a scaled drawing, use formula to determine the resultant. Determine the resultant. What formula do we use? You see, by realigning their directions, F2 and then F1, they are perpendicular to each other. So once they are perpendicular to each other, they look like the right angle triangle. They look like the right angle triangle. Where if there's the angle in question, theta, it means there's the adjacent. F2 is the adjacent. F1 is the opposite. And what is this line? What is the diagonal? The diagonal line, which is the resultant. The resultant represents what? The hypotenuse. Okay. Giovanni, your hand is up. Let me hear from you.
Sir, please. Sir.
Giovanni, I'm listening. Giovanni, I'm listening.
Sir, please, the formula you gave us, sir, please, is it used when there is a scale drawing or no scale drawing? That part, I didn't get it.
So, the triangle law of vector addition, which is after realigning their direction, FR is equal to F2 plus F1, or it is F2 plus F1 when you look at it from above. When you look at it from below, this is above, this is below. When you look at it from below, you can also see that FR is equal to F1 plus F2. So it means this is what I'm calling as a triangle law of vector addition. And the triangle law of vector addition obeys the commutative rule of addition. Okay, that's irrespective of how you add it, F2 plus F1 will still be equal to F1 plus F2. So it obeys the commutative law of addition. This can only be used to find the resultant when it is a scaled, when you have a scaled drawing. When you have a scaled drawing. If the drawing is not up to scale, use formula. And that is what we are coming to discuss. Giovanni, are you okay?
Yes, sir. Sir, please, another question.
Okay.
Sir, please, Pythagoras theorem in calculating for when you are using the triangle law of vector addition.
Come again.
Can you use Pythagoras theorem when you are using the triangle law of vector addition?
Okay, well said. I'll answer. Listen. So you can only use this when you have a scale drawing. If you don't have a scale drawing, use formula. And what is the formula? Since F1 is perpendicular to F2 and the diagonal represent the hypotenuse, you can use Pythagoras theorem in this case. We have to use Pythagoras theorem because the angle between F1 and F2 is 90. So you can deduce that the square of F resultant is equal to the square of F1 plus the square of F2. And this is what Giovanni, you are calling as the Pythagoras theorem. So when two vector quantities are perpendicular to each other, the resultant force is determined using Pythagoras theorem. But before you do that, you must realign their directions to follow a certain order. Giovanni, is that okay?
Yes, sir.
Okay. Now the direction of the resultant. Looking at our diagram, the resultant force is between southeast. Southeast. This is east, this is south. So the resultant force acts within southeast. So let's calculate for this angle. Theta, what I've indicated as theta to the x or to the from the east or from the x axis. Let me clear this space quickly. Emerald, are you following? Anna and the rest of you? Anita, Ida, Yasmin. I wish I can mention all names. Frank, your hand is up.
Please, I don't understand.
Which one?
Sir, I had to disconnect and come back because of my microphone. So the whole of this page, I wasn't able to hear what you're saying.
You don't worry. We'll solve the question I gave you. So it will be fine. So
Okay, sir.
once F1 is perpendicular to F2, we can determine the resultant using Pythagoras theorem. And we want the direction of the resultant. Okay. And here, this direction, we are looking at the direction from east, or you can also determine the direction from south. Okay. So to determine theta, that is the direction the resultant makes with the east. With east, the x axis or the x axis, we can take the tangent. Since we have the opposite, which is F1, and we have the adjacent, which is F2, we can find theta. So tan theta is equal to F1 divided by F1 is the opposite and F2 is the adjacent. So F1 divided by F2. So that theta will be equal to the tan inverse of F1 on F2. This is the direction of the resultant, okay, to the x-axis or from the east. If you want to determine the direction of the resultant from the south, or negative y-axis, you see, this whole angle here is equal to 90. So subtract theta from 90, and it will give you the angle it makes with the south or with the south. So angle the resultant force makes from the south must be 90 minus theta. 90 minus theta. The other point is that, you see, for bearings, angular measurement is taken from the north. So this is the north axis. This is the north. This is the south. This is east. So if you want to follow bearings where angular measurement is taken from the north, after getting theta, what is the angle from the north to the east? What is this angle from the north to the east? Hello, what is this angle from the north to the east? Oh, anybody? The angle from the north to the east axis. What's the angle?
90.
Come again, Prempoma. I mean this angle. This is 90. The angle between north and east is 90. So if you want to take your angular follow bearings, then after getting theta, you add 90, and that will give you the direction of the resultant from the north. And if you write it this way, then you want to follow bearings. Okay. So whatever degrees north of what? South. Or what? So let's go to the main question I gave you. The understanding will come. So you are given two vectors, one due south, one due east of. First, help me determine the magnitude. First, help me determine the magnitude of the forces, of the two forces. It is obvious if you have a question like this, use Pythagoras theorem, because this is not a scaled drawing to use the triangle law of vector addition. So quickly help me determine the magnitude, class. I'm waiting for you. Harry.
Sir, 234 Newton.
Come again.
234 Newton.
I have more views. I'll confirm. So if you had a different answer, let me know. All right, let's see. So once F2 is perpendicular to F1, the resultant will act along the diagonal downwards like this. Okay. It will act along the diagonal. So F resultant squared will be equal to F1 squared plus F2 squared. F1 is 15 Newton. So 15 squared plus 30 squared. What is 15 squared? Plus, what is 15 squared?
125.
So 125.
225.
This is 225 plus 30 squared.
900.
Add 900 to 225.
1,120.
1,125. Therefore, FR is equal to the square root of 1125. And what's the square root of 1125?
33.54.
Up again.
33.54.
Okay. This is 33.54
0.54.
Newton. So Eric, look at your work again. Okay. So this is the resultant force. What is the direction? The direction, this is the resultant. It's along the diagonal between the diagonal along the fourth quadrant. So this angle must be known first. So if I take tan of theta, tan is opposite, which is 15 divided by the adjacent, which is 30. So I have half. So what is the tan inverse of half? Tan inverse of half. Please calculate that for me. Tan inverse of half. I'm with you. Tan inverse. So press on shift.
26.56.
26.56.
Give me the answer in 2 decimal places.
26.57.
57.
Okay. So what it means is that the resultant makes an angle of 26.57 from the east. From the east. This is direction. Meaning when you are at the east, you can follow the direction of the resultant when you turn through this angle. Or when I'm at the south, I must turn through this angle in an anti-clockwise direction. Okay, to face the resultant. And how do I determine the angle from the east? The whole angle from east to south is 90. So when I subtract 26.57 from 90, I have the angle from the south. What's the angle here? What's the angle here? 90 minus 26.57.
63.43.
63.43 degrees. Okay. So 63.43. Okay. East of south. Southeast. 26.57. Okay. East of south. Now, if I want to follow bearings, for bearings, angular measurement is taken from the north. So all angles must be measured from the north. 10. This will be the angle for bearings. Okay, I have theta, meaning if I'm from the north, to get the direction of the resultant, it is 90 plus 26.57. And what is 90 plus 26? 26.57. This is
116.57.
Okay. This is north of what? North of what?
East.
North of
East.
or south. It's south. Northeast is within this. Northeast is within the first quadrant. Northeast is here. South or east is here. But this is 116 degrees from the north, okay, getting to the south. So this is the angle when it comes to for bearings. So it actually depends on how the question is framed. If it's general direction, you go by this. If it's from east, you go by 26. If it's from south, this is how you take the 63 points. Giovanni.
Sir, please, I don't understand why we use the tan to calculate it, to solve, why we added the tan into the equation.
We are looking for the direction. We are looking for the direction. We know this. We know this. This is perpendicular. So if the resultant acts in this direction, and you know the opposite, you know the adjacent, and both are perpendicular, obviously, because you have F2, you have F1, the obvious trig ratio to use is tan. Of course, you can also use sine and cosine because we've now found the resultant. Okay, so I'm using the tan because we were initially given F1 and F2. That's all. Giovanni, are you okay?
Yes, sir.
But that does not mean you cannot use sine and cosine. Once you have the resultant, you can also use that to determine the angle, theta. Okay, so I want you to answer the 2B question. We have a displacement of 150 centimeter due north, and then a displacement of 60 centimeter due east. What is the resultant displacement and the direction? Start with. And the direction of the resultant. Okay, here use bearings to determine the direction. Give me angles using conventional method, which is bearings. And bearings, angular measurement is taken from the north. You must be through by now. That's not a difficult question. Are we through? Are you there? Hello, are we there?
Yes, sir.
So when you realign directions, okay, when you realign the vectors, you create equal vector of this, place it on the head of this one. The equal vector must have the same direction as the original. So you can call this as D1. Even doing it for D1 alone, the direction is now clear. Okay. If D2 is moving due east and D1 is moving due north, then the resultant will be drawing a vector from the tail of D2 to the head of D1. Let's assume it ends here. And don't forget D1 is perpendicular to D2 by this relation. Okay. And so this becomes the resultant, D. So D squared, the square of the resultant, Pythagoras theorem, is equal to 60 squared plus 150 squared. This is 3600 plus
22500.
22500. So when you sum them up, what do you have?
26100.
So 26100. Therefore, D is equal to the square root of 26100, which is
161.55.
come again.
161.55.
161 point
55.
55 centimeter. What's the direction of the resultant? That the angle it makes with the X or to the due east is this. So once I have the opposite to this angle and then the adjacent, tan of this angle is equal to 150 over 60. And this is equal to 5 on 3. What's the tan inverse of 5 on 3? Yes. So take the tan inverse. Giovanni,
59.
I'm listening, Giovanni.
Sir, please, is it 5 on 3 or 5 on 2?
This is 5 by 3. That's 2. It's 2. 5 on 2.
Sir, please, the tan inverse is 68.19 degrees.
Give it to me.
8.20.
68.
20.
0.98.
Okay. So let's take approximate it to 68. What it means is that this resultant displacement, Anita.
Yes, sir.
Anita, I'm listening.
Sir, please, I don't understand why we put the theta at the left corner. I don't know why I don't get it.
Oh, we can put, you see, because we have opposite, we have adjacent, you can easily find this first. Find this angle between, okay, the angle, the resultant mixed with the x first, because we have the opposite, we have the adjacent before you can determine this. So that is why I'm indicating theta, okay, within here, because we have all that it takes to find theta first. Anita, are you okay? Anita, are you okay?
Yes.
Okay. Elikem.
Sir, please, the tan inverse of the 5 on 2, can I write it in two decimal places?
You
Or the
can
first time I
even,
wrote it in two decimal.
oh, it doesn't matter. You see, usually for angles, you see, on the angles, the least angle is 1 degree. So we don't have 68 point something. You can't measure that using a protractor. So that's why with angles, we run it to the nearest angle. Okay.
Okay.
So Anita, once we have this, we can then calculate for the angle the resultant makes with the north or with the y-axis. And that is 90 minus 68 degrees. Are you okay? So the 68 means that the resultant makes an angle of 68 degrees from the east. So when you measure 68 degrees, okay, counterclockwise, you can locate the resultant. Now, if you are at the north and you measure an angle of, yes, an angle of what? 20, is it 22? Yes, 22 degrees.
Yes, 20.
You can also locate the resultant. All right. So that's the direction of the resultant. So in short, when two vector quantities are perpendicular to one another, first you realign their directions if their directions are in a disarray. Then after realigning their directions, you can use Pythagoras theorem when it's not a scale drawing. If it's a scale drawing, you can determine the resultant by just adding F1 and F2. And then if it's a scale drawing, this plus this, when you measure from here to here, it must give you the same thing as when you have added 60 to 150. And that is if it's a scale drawing. Okay. So on a scale drawing, 60 plus 150, what this will give you must be, the sum of this must be the same as from here to here. All right. But if it's not a scale drawing, use Pythagoras theorem to determine the resultant. Okay, I'm just reading the messages. So, and Emelda, you see the purpose of the tan, I'm using tan because I have, this is the angle the resultant makes with the x-axis or east. Okay, so for this angle, I have the opposite D1, I have the adjacent D2. And so once you have opposite and adjacent, you can use the trig ratio tan to find the angle. Then you can use the angle to find the angle it makes with the y-axis. So that's why I'm using tan. But once we have the hypotenuse, we can also equally use cosine. We can equally use sine. Are you okay? And the answer must be the same. Emelda, are you fine?
Yes.
All right, class is 2 minutes past 12. This is where we draw the curtains on our meeting today. Gideon, last question from Gideon, then we end the day.
So can you send today's video to the group?
Pardon?
So please, can you send today's video to the group?
Oh, I'll upload the video. Okay.
Okay, so thank you. Okay, thank you.
All right. Yo. Bye-bye and take care of yourselves. The assignment will follow. Augustine, what you must write as your final answer, I told you that conventionally, okay, whether you are taking it to X, due is or due not is direction. So usually the question will be specific. Determine the direction of the resultant. And it can be due north when you take it from north or when you take it from the east. Both must give you the same, okay, or both indication of direction is right. Imelda.
So said the first one, the d square is equal to 60 square plus 150 square. That's the magnitude. And then the second one is the angle.
The direction.
Direction.
Okay,
Thank you.
so 161.55 centimeter is the magnitude of the resultant. And when we determine theta, is the direction it makes either with the x-axis or the y-axis. Okay. All right. And class, bye-bye. I'm already exhausted.